Okay, so yesterday we graphed a little bit and we just typed the thing in the calculator and we found our little starting point. So today we're going to talk about what actually happens when you have numbers and stuff added to this function. So we're looking at y equals the square root of x is all that we're going to be graphing. So the first one is if you have a negative out front. So if you have a negative out front, what happens is you reflect over the x-axis. So if you have a negative inside, you reflect over the y-axis. Okay. So then the next two we have adding and subtracting outside of the square root. So anything that happens outside of the square root is going to be a vertical change. So if we have plus c, which of course is a number, outside of the square root, then that means we move up c units. So whatever c is. Okay, so plus on the outside, you're moving up. So if plus moves up, what do you think minus does? Down. So move down c units. So anything on the inside moves you horizontally, so left and right. But the thing about when they're inside, it's always the opposite. So if we have plus c, you move to the left. C units. Okay, so plus inside moves to the left. And then minus on the inside moves to the right. Okay. Questions about those? Up, down, left, right. Okay. So for our first two, we had negative 1, because you know there's always an invisible 1. So then these last ones are when you have a number other than 1, so 2, 3, or something like that. So let's say in this first one that c is greater than 1. Okay, so it doesn't matter if it's negative. The negative is the flip. You're just wanting the number part. So you think like absolute value of c. So just what is the number? So if that's greater than 1, then that is a vertical stretch. Okay, so it's taking that little curve and it's pulling it up. But if c is less than 1, so again, not a negative, but like the number, so it's a fraction or it's a decimal that's less than 1, then that's a vertical shrink. So it squishes that graph down. Okay. So greater than 1, it's stretching it, so it's growing faster. Less than 1, it's shrinking it, so it's growing slower. So then if it's inside, those are horizontal. But again, it's the opposite. So if C is greater than 1, rather than a horizontal stretch, it's a horizontal shrink. Okay, so it's the opposite. Okay, so it takes the width and it squishes the width of it closer together. And then if C is less than 1, it's a horizontal stretch. Questions on any of those? Okay, so let's graph our original graph. So your original graph is called the parent function, and so that is just the square root of x. So that's what the graph looks like without any numbers or anything altering it. And so without anything changing it, it always starts at 0, 0. And then your next point is always up 1 over 1. Unless you have a stretch or a shrink, then that changes. And then our next point is at 4, 2. And then it curves up like this. So those are our 3 main points. Our next one will be at 9, 3, but that goes off of our graph. So if you want to know where those come from, you can always type them in and say square root of x, and then look at the table. And then just like we did yesterday, we don't want the errors, so if we look at our first point, there it is, 0, 0, 1, 1, and then our next nice point is at 4, 2. Okay. So those are where those points come from. Questions? But let's move these points around without graphing them. Let's do it by hand. So if I look at this next one, we've got the square root of x plus 2. Well, what is plus on the inside? How does that move? Good, left. So we look right here, plus on the inside moves left, and we've got a 2. So we're going left 2. So all we have to do is what we did in Unit 1, and just move our points to the left 2. So instead of being at 0, 0, I'm going to go left 2. So 0, 0, left 2 is here. So now I'm at negative 2, 0. So then we move our next point. So our point was at 1, 1, so we go left 2. So then we're at negative 1, 1. So you're always moving these original 3. So then 4, 2, if I go left 2, I'm at 2, 2. And there it is. So same exact graph, just all moved left 2. Questions? Alright, so let's look at our next one. So our next one has 2 things going on. It has a negative out front, and it has a plus 3 on the outside. So what does that negative out front do? Good, so it's going to reflect over the x. And then what does that plus 3 do? It's on the outside. Good. Up 3. Good. So we're going to reflect over the x, and then we're going to go up 3. Okay. So again, we're still starting with our original 0, 0. Well, if I have to reflect that over the x-axis, nothing happens. So I'm still at 0, 0, and then I'm just going to go up 1, 2, 3. So now I'm here. Okay. So since it's on the x-axis, if you reflect it, it doesn't move because it's already on it. But then our next point, 1, 1, if I reflected it, I would be at 1, negative 1. Okay, so same reflection from unit 1. So I reflect it over, and then I go up 1, 2, 3. So now I'm at 1, 2. Okay. So then my next point at 4, 2, if I reflect it over, I'll be at 4, negative 2. And then I go up 1, 2, 3. So I'm at 4, 1. Yes, these first three are always your original points. Those are always the ones that you're moving. Questions? Okay. So our next one, we have a 2 out front. So we know it's going to be vertical because it's outside, but is it a stretch or a shrink? A stretch, because 2 is greater than 1. So it's harder to do these by hand, but what happens is our y values are multiplied by 2. Now, if you don't know that or you can't remember that, you can still type it in just like what we did yesterday. So you can say 2 square root of x. And then if you want to see what it's going to look like, you can graph it. And then you can look at the table. So again, we want that first point, which is 0, 0. Well, if I think about it, 0 times 2 is 0. So that point doesn't change. But then my next point was at 1, 1. Well, now it's at 1, 2. So again, if you multiply that y by 2, 1 times 2 is 2. So we're at 1, 2. And then our next point, instead of being at 4, 2, we're at 4, 4. Because again, 2 times 2 is 4. So 4, 4. Okay. So a stretch or a shrink, easiest way to do it is type it in the calculator. Just because they're a little bit different. But if you look at it, it's the same shape, but it just grew faster. So it was stretched vertically. That's what that's called. Questions? Alright, let's look at 5. So on 5, how is this one going to move? If I have a minus on the inside, how does that move? Yeah, but how does it move? Yes, good. So it goes to the right. So we're going to go to the right 1. And then how about that plus 4 on the outside? Good. Up 4. Good. So we're going to go right 1, up 4. Okay. So again, we're looking at our original graph. So I'm at 0, 0. So 0, 0 goes to the right 1, up 1, 2, 3, 4. We'll just put it off to the side on this one. So then our next original was at 1, 1, so we go to the right 1, 1, 2, 3, 4. And then our original 4, 2 goes to the right 1, 1, 2, 3. Oh, that's not right. So we're here, so we go to the right 1, 1, 2, 3, 4. Yeah, there we go. Did you move this one? The first one? So it should be, we should be at 4, 6. So 1, or 5, 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Yes. Yeah, you're always moving this first one because this first one is your original. Yeah. Oh, we didn't write this. So sorry. This was a vertical stretch. Questions. All right, let's look at one more graph. Let's look at number 6. So I have the 1/2 inside, so I know it's going to be horizontal. But if 1/2, is that less than 1 or greater than 1? Less than 1, so it's going to be a horizontal stretch. And so the first one, it was vertical, we multiplied our y's by 2. This one is horizontal, so our x's are the ones that get multiplied. But again, it's kind of strange, so let's just type it in and see what happens. So the square root of 1/2 x. So again, we can graph it and see what it looks like. Looks pretty similar, but let's look at what happened to our points. So our first point, 0, 0. Again, that doesn't change because 0 times anything is 0. But then our next point was at 1, 1. Well, now it's at this weird 1.7 whatever. So now if I look at this point 2, 1, that's my next point. So 2, 1. And then again, my point at 4 got messed up. So let's see where our next point at 2 is. And it's at 8, 2. Does that fit? 1, 2, 3, 4. So 8, 2 would be about right here. So again, our y's were multiplied when it was a vertical stretch, and this one, our x's were multiplied. Okay. And so you can see it took that graph and it stretched it horizontally, so it made it longer than it was before, so to speak. Any questions about graphing? And you can always graph every single one of them in the calculator if you want to, but yeah. 3, yeah. Yeah. Oh, sorry, yeah. So reflect over the x and up 3. Okay, so then the last thing we're going to do is we're not going to graph these, we're just going to describe what's happening. So if we look at number 7, we have 3 things going on. We have this 2 out front, we got this -8, and we have this -10 on the outside. So if I have a 2 on the inside that's being multiplied, is that a a horizontal shrink or horizontal stretch? Shrink. Good, because 2 is greater than 1. So that 2 gives us a horizontal shrink. What is that -8? How does that move it? Good. To the right 8. And how about the -10? Good. Down 10. Good. Questions? Alright, let's look at 8. So 8, we have 2 things. We've got the 2/3 out front, and then the +1 inside. So if I have 2/3 out front, is 2/3 greater than 1 or less than 1? Less than 1. So then I go to less than 1 out front. Good. Is a vertical shrink. Good. Oop. Can't spell. Good. And then how does the +1 move it? Good. Left 1. Very good. Questions. Alright, last one. So on this one we only have 2 numbers, but we do have that negative. So we have 3 things going on. We've got the 2, we've got the negative, and we've got the 3. Okay, so again, the negative is one thing, the 3 is one thing. So what is the 2 going to be? So it's outside, so it's going to be vertical. Stretch or shrink? Good. Stretch, because it's greater than 1. Maybe one day I'll learn to spell. Okay, how about that negative inside? What does that negative inside do? Good. Reflect over the the Y. And then the last thing, how about that 3? It's inside, so it's going to be horizontal. But stretch or shrink? Well, is 3 greater than 1 or less than 1? Good. It's greater than 1, so it's going to be a shrink. Good. And that's that 3. And so these same rules apply to pretty much any kind of graph. So whether you're doing a square root, whether you're doing an x squared, and later we'll talk about rationals. And so they all these rules apply to the same ones. Question.